Welcome to the notes for 5-1. Today's lesson is titled, How are X and Y related? We're going to focus on direct and inverse variation functions today. As we progress through the chapter, we're going to look at stretches and shifts of the parent graph y equals 1 over x, and then we're going to end chapter 5 by talking about the concept of a limit. Okay, so variation equations are just different ways of talking about how one quantity changes relative to another quantity. Okay, so in direct variation, okay, as one number increases, so does another. Okay, so as one number increases, so does another. So if one thing is increasing, so is the other one. They're both increasing. So an example you'll see here says if y varies directly as x, then we say that y equals k times x. So in this example, okay, just some things to notice here, right? You're going to see this statement a lot. It says varies directly, okay? When y varies directly as x, that means if y is increasing, then x is increasing. If y is decreasing, then x decreases. And there's a little equation here that you'll see that we'll use quite a bit as well. So y is equal to k times x. So as y increases there, our x is going to increase because we're going to be multiplying it times whatever our k value is. K, we are going to call the constant of variation. Okay, so typically we're not going to be given the value of k. We are going to have to find it based on information that we're given in the problem. Okay, now to go along with direct variation, there's also what we call inverse variation. And that's when one number increases, the other one is going to decrease. So now they have an inverse relationship. As one number gets bigger, the other one is going to get smaller. So again, just an example. It says if y varies inversely as x, then we say that y is equal to k divided by x. Again, k is our constant of variation. Okay, but you just need to remember this kind of setup of the equation. Okay, so in one of them, right, we have k and we're going to multiply it by x. In the other one, we have k and we're going to divide it by x. And we'll talk a little bit more about it here as we see some of the examples. So it says, suppose we know the area of a rectangle was 24 square feet. It says, write an equation relating the length and the width w. So our length L and our width w. Well, we know that length times width is area. So in this case, since we know the area is 24 square feet, we could say length times width is going to equal 24. Okay, so we see the relationship there. Now it says determine if this equation is an example of direct variation, inverse variation, or neither. Well, if I'm going to do L times W equals 24, if I took this same equation and I wanted to isolate one of the variables, let's say I wanted to isolate my L, I'd divide both sides by W, and we now have the equation length equals 24 divided by W. So this one is going to more closely resemble, right, our equation down here. So this is an example of inverse variation. Okay, and it wouldn't matter if we switch the variables, right? If we said length times width equals 24 and then we divided each side by the length, right? It still ends up giving us that relationship here where we've got W now equals 24 divided by L. Okay, so this is an example of inverse variation. Okay, so this is an example of inverse variation. And we know that because, right, we could say as L, we'll say as the length gets bigger, the width gets smaller, and vice versa, right? It could happen either way. All right, and let's just talk about that for a second, right? Because think about it. If the product is 24, right? Let's say my length was 12. So that means in order for my area to be 24, right, if my length was 12, my width would have to be 2. Okay, well, if we decrease our length and make our length, right, it's going down, it's going to become 6. That means we're going to have to increase our width to 4, right? So as the L goes down, the W goes up. 6 times 4 gives us 24. So as one of our quantities, gets either smaller or bigger, the other one's going to do the opposite, right? Because we still have that product of 24. All right, so looking at some examples. It says, if y varies directly with x squared and y equals 2 when x equals 4, find y when x is 2. So the first thing that we're going to want to do here when we're dealing with these is we're going to try to set up an equation to find our k value. Okay, so we want to find our k value. So we know since y varies directly with x squared, right, we could set this up and say this is going to be y equals k, right? And since, remember, varying directly is when we multiply the input times k, it would be k times x squared. Okay, so that's our direct variation. So in order to figure out what k is, we're going to use this given info that y equals 2 when x equals 4. We're simply going to substitute in our 2 and our 4 into the equation. All right, and then we're going to solve it. So 4 squared is 16. 16k equals 2. So when we divide by 16, we're going to get 1/8 is going to equal k. Our constant of variation is 1/8. Now, what are we going to do with that? Well, we're going to take that 1/8 and we're now going to substitute it into the equation. We've got y is going to equal 1/8 times x squared. Okay, so when we're solving the rest of it here, right, because they want us to figure out what y is when x is 2. So we'll just leave y as it is, and we'll say this will be 1/8 times 2 to the second power, which gives us 4, and then we've got 4/8, right, which actually ends up being 1/2. So our y is equal to 1/2 when x equals 2. So that's kind of like our answer there. Y equals 1/2 when our x equals 2. Okay, let's look at another one. Suppose that f of x varies inversely with the square root of x. If f of 4 equals 1.5, find the value of x when f of x equals 6. Okay, so remember, f of x, right, this is like our output. It's like our y. So it's telling us that it varies inversely with the square root of x. So make sure you're reading carefully, especially when it's talking about squares and square roots. So let's just set up that basic equation first, right? So we're going to do f of x would equal our k. And then since this time we're talking about varies inversely, we know that we're going to divide k by whatever else we find there. So that would be what, our square root of x. So we're going to say the square root of x. Okay. And they give us this point, right? F of 4 is going to equal 1.5. And I think, we know that, right, our input is 4, our output is 1.5. It's like the 0.4 comma 1.5. So let's put in our 1.5 for our f of x. We've got our k here, and then we're going to divide by the square root of 4. So 1.5 is going to equal k divided by 2, which means that k is going to equal 3. So now that we know what k is, right, again, we'll just take it here and we'll substitute that into the equation. We have f of x is going to equal 3 divided by the square root of x. And now we'll just use this, right? So we're looking for our input value because we have x comma 6. Our output is 6. Our input is x. So we're going to say 6 equals 3 divided by the square root of x. And with this one, you could take it here and cross multiply, right? Treat it like it's a proportion or cross multiply. You can also just do, swap your values. You could say this is the square root of x would equal 3 divided by 6. And then we know 3 divided by 6 is really 1/2. So the square root of x is equal to 1/2, and then we'll just go ahead and square both sides, and we will get that x equals 1/4. So we know here that f of 1/4 should equal 6. All right, moving on. Okay, so there's a number of word problems in this, so you just got to take your time and read it carefully. The first one says water temperature in an ocean varies inversely. Okay, so it varies inversely to the water's depth. So some of those key words. So it looks like our temperature, right? Our temperature is going to vary inversely to the depth. So as I take this and write this out, I know my temperature should equal K divided by our depth. Okay, so we can actually just, we can use variables. We'll say T equals K divided by D. So now we know what those all mean. Okay, so it says at a certain point in the Atlantic Ocean, the depth of the water is 500 feet and the temperature is 28 degrees Fahrenheit. Okay, so when we think about that, right, looks like our output is our temperature. So as we think about writing this as like as ordered pairs, this would be like depth, comma, temperature. So our depth here was 500 feet, and our temperature was 28 degrees Fahrenheit. So let's substitute those in to figure out what our constant of variation is going to be. So we'll say our temperature, 28 degrees Fahrenheit, is equal to K divided by 500. We'll solve for K, multiply both sides by 500. So 28 times 500, I believe, is 14,000. All right, and so now that we know what K is, let's substitute it back into the equation. We've got T is equal to 14,000, and we're dividing it by D. And then that second part of our problem says, at what depth would the water have to be to have a temperature of 18 degrees Fahrenheit? So we're thinking here, trying to figure out what our depth would be so that our temperature is 18 degrees Fahrenheit. So we're trying to figure out the number of feet. So let's take it and substitute in what we can, right? We're going to say 18 is going to equal 14,000 divided by D. Again, cross multiply, do what you need to do. You've got D equals 14,000 divided by 18. And let's see, do I have a calculator on here? I don't. So let's see, I believe that ends up being 777.78 feet. So that is the depth that we need to be at there for the temperature to be 18 degrees Fahrenheit. Okay, so if you have questions, make sure you're marking them down and reach out to me however you can. The next example says, Kepler's third law of planetary motion states that the square of the time, t, required for a planet to make one revolution about the sun varies directly as the cube of the average distance, d, of the planet from the sun. They want us to write an equation that models this law. Okay, so it states that the square of the time, t, okay, required for a planet to make one revolution about the sun varies directly as the cube of the average distance d. So we'd say here that our time squared should equal k, and then since it varies directly, right, we're multiplying times the cube of the average of d. So we're going to say d cubed. Okay, actually, here, since we're writing out the words on that one there. So our average distance cubed. So to write the equation then, right, we'll abbreviate time with t. So t squared should equal k times d to the third. That's all they ask us to do on that one, so we should be pretty good there. Let's move on. Next one says, suppose y is directly proportional to x and inversely proportional to x plus 1. if y equals -1 when x is 4, find the value of x when y is 3. Okay, so this one's a little different, okay, because they're saying that y is directly proportional to x, and it's inversely proportional to x plus 1. So we have multiple things going on in this equation. So we'll start with y. Okay, so I'll put my k over here, y equals k. So it says it's directly proportional to x. So now I guess I should talk about this. Directly proportional is just another way to say it varies directly. Okay, I'm sure you probably figured that out already. But then inversely proportional also means like it varies inversely. So it's just another way of saying it. Okay, but look for those, those core words, the inverse and the direct. So we're going to do y equals k times x. But then remember, it's inversely proportional to x plus 1, so we're going to divide that by x plus 1. Okay, and then we're going to do the same thing. This just adds a little bit to our original equation. So if y is -1 when x is 4, we're going to put those in. -1 is equal to k times 4 divided by 4 plus 1. We'll go ahead and simplify. We got -1 is equal to 4k over 5. Multiply both sides by 5/4. We should get -5/4 is equal to k. So there's our constant of variation. Let's plug that into our equation. So we have y is equal to -5/4 x over x plus 1. And then we'll take it here and we're going to find the value of x when y is 3. So we'll put 3 in here. We've got -5/4 times, actually, yeah, y was 3. So then we're going to put in, we're trying to find the value of x, so we'll leave x in there. And now we're just going to solve this equation. So let's just cross multiply. We're going to have 3 times the quantity of x plus 1 would be 3x plus 3 equals -5/4 x. I'd take that and say, hey, let's just go ahead and multiply everything by 4 to get rid of the fraction. Just make it a little bit easier. So we've got 12x plus 12 is equal to -5x. I'm going to subtract 12x. Right, this is just the basic algebra part of it. And then we get that x is going to equal -12/17. And that is our answer. Now I'll show you in class there if you want some more ways to like check to make sure everything's correct there. Just don't want to take up too much time in the video to do that. So that is our answer for this one. So remember, sometimes you have more than one thing going on. And that actually will end up happening in this last one too. So we've talked about direct variation and inverse variation, okay? But there's also what we call joint variation. And it's not hard. It just represents a direct variation between 2 or more variables. Okay, so an example for that. It says, suppose x varies jointly with y and the square root of z. Okay, so if we're trying to set that up there, so the first letter, right, is x. So we're going to say x equals, we've got our k here, and then we're going to say, if it's going to vary jointly, we're going to say times our y, and then we're going to multiply times the square root of z. So that is what our equation looks like. So remember, joint variation, you just have more than one thing being multiplied on the one side of our equation. So let's take it here and figure out what k is. So it says when x is -18, y is 2, and z is 9. Okay, they want us to figure out here what our value of y will end up being. So the square root of 9 is 3 times 2 is 6. So we have 6k is equal to -18. We'll divide each side by 6, and we get -3 is equal to k. So now we've got x equals -3 times y times the square root of z. And we're going to be looking for what y is, so we're going to plug in 10 and 4. So we're plugging in 10 for x, equals -3 times y times the square root of 4. Well, the square root of 4 is 2 times 3 is -6. We have -6y is equal to 10. And then we're going to divide each side by -6, and we get -5/3 would equal our value of y. Okay, so with this one, like I said, when it varies jointly, okay, everything is being multiplied times k. So what we're really looking at here is, as our value of x increases, right, so will the product of y times the square root of z. So that product will increase. As x decreases, that product between those two will decrease. It's not between the individual parameters or variables there. All right, that's all we got for this lesson. Hopefully this helps things to make sense. If you have questions, please make sure you're reaching out. I look forward to hearing from you if you need anything.